Hi Calculus, we're going to look at examples 2 and 3 from 8.4, finding the area between two curves. These are pretty straightforward problems, so I'm hoping they feel like a good reminder of what we did last week and get you ready for class tomorrow. It says find the area of the region bounded by the graphs of f of x is equal to 2 minus x squared and g of x is equal to x. Well, to know what's going on here, it's probably not a bad idea to draw a picture. So I know the line y equals x. Oops, looks something like this. Goes through the origin, has a slope of 1. Sorry, not great, whatever. Y equals x, and this is g of x. And then f of x is 2 minus x squared, or negative x squared plus 2. So I know it's a parabola that opens down, that's going through, has been shifted up 2. Now, if you're unsure exactly where it's going to kind of hit, let's think it through. You could either plug in a point. So let's say what f of 1 is. F of 1 would be negative 1 squared plus 2. 1 squared is 1, negative 1 plus 2 is a positive 1. So I know that these are going to intersect at the same spot. Again, this line is a little bit off. And you could even look to see, maybe I plug in negative 1. F of negative 1 is going to be negative 1 squared. Oh, well, that was a silly thing. We know it's right over here because it's a parabola. Sorry. Or f of negative 2 maybe would be negative 2 squared plus 2. It would be negative 4 plus 2 or negative 2. And so negative 2, we see that's our other intersection point. The area between these curves would be this shaded region right here. And one other thing to note is if I wanted to find these intersection points, because now I see that they intersect at 1, 1, and at negative 2, negative 2. But if I was looking for their intersection, the other thing we could do is set them equal to each other. 2 minus x squared is equal to x. I'm going to move everything to the right side. 0 is equal to x squared plus x minus 2. This is very easy to factor. X plus 2, x minus 1 is equal to 0. And I solve x is equal to negative 2 or x is equal to 1. These are the x values where my two functions are equal to one another. Now that we have our drawing, it should be relatively easy to set up our integral. Remember, we are looking for the area between these curves. So we're looking for that yellow shaded region. If I want to find the area between two curves, I'm going to take the integral of the upper function minus the lower function. So the integral of 2 minus x squared minus our line, minus x, and my bounds are going to be where they intersect. So from negative 2 to positive 1. Of course, you can rearrange this and you could integrate it by hand. I am simply going to give you the answer of 9/2. Either take some time to make sure you know how to put this into your calculator or do it by hand. This is a very easy integral to calculate, so not a bad one to practice on your own. Same type of problem, finding the area between two curves. It says find the area of one of the regions bounded by the graphs of sine of x and cosine of x. Sketch the graph and shade the region. So notice they give us an axis that's labeled pi over 2, pi over 4, 3 pi over 2, 2 pi. I know that sine goes through the origin, it goes up to the midline, down, back to that midline. So sine is my red curve. Cosine does the same movement, but starts at 1 to the midline, down, midline, up. So cosine of x, and they say find the area of one of the regions bounded. So notice this area right here is going to be the same as this area right here, is going to be the same as this area. They are only asking for one. I am going to focus on this right here. So I can see from my graph the upper function is cosine, the integral of cosine x minus sine of x with respect to x. But what are my bounds? We can either look at our graph. I see they intersect here and here. Between 0 and pi over 2 would be pi over 4. And between negative pi over 2 right there and negative pi, this would be negative 3 pi over 4. So from negative 3 pi over 4 to positive pi over 4. Again, the other way you could do this is ask yourself, where are sine and cosine the same? If we think about our unit circle, sine and cosine are the same at pi over 4. They're also the same at 5 pi over 4. But notice how we need this negative version, so they named it negative 3 pi over 4 in the opposite direction. Same thing with the last problem. Take a moment if you want to calculate this by hand. However, you can also plug that into your calculator. And I got 2.8284. If you don't get that and you are certain you plugged it in correctly, make sure your calculator is in radians. Have a good rest of your day. Whenever you watch this, let me know if you have questions.